Hello, welcome to my channel. In this video, we are going to be taking a look at a problem under density, and the problem we want to solve has the statements below. So, if an alloy made of aluminum and gold weighs 45 Newton in air and 34 Newton when completely immersed in water, what is the weight of gold in the alloy? The density of gold is given as 19.3 times 10 raised by 3 kg per meter cube. Density of aluminum is given as well, while the density of water is given as this expression. So to solve this problem, let's take a pictorial view of what this diagram, this question is all about. So we have the gold alloy, the gold aluminum alloy, totally immersed in liquid, and this scale reads 34 Newton when it is totally immersed. But if it is not immersed in water, this scale will read 45 Newton. So if you look at this diagram, one of the forces acting on this particular body is the weight, and which is given as W, which is the total weight of this alloy. And another force that is acting on this system is the buoyant force, which is given as B. And finally, tension measured by this particular string. And that one will be pointing towards this direction, to pointing upward. So the equation for that system is given as B plus T, because the tension in this string, the measurement is equal to more or less like the tension in this particular spring. So we have our B, buoyant force, plus the tension must be equal to the weight, total weight of the system, right? So we can simplify by making B the Sevier formula. We have B equal to the total weight minus the tension. But mind you, our buoyant force is also given by this expression below, which is the density of water displaced times acceleration due to gravity times the volume, the total volume of the liquid displaced. Or this V is also the total volume of this block. It's either the total volume of the block or the total volume of liquid displaced. So take note of that. So now that we know our B equal to this, we can replace B here by this expression, and we have rho of water, G, and V total equal to this expression minus this expression. We know this one, which is the weights in air, and this one is the measurement done by the spring, and they are given to us by 45 minus 34, which is equal to 11 Newton. So we have this expression equal to this. And from this point, we proceed to making V total the Sevier formula, which is equal to 11 Newton all over rho of water and G. Right, so we move on to the next part, which is we have our V total equal to 11 Newton all over the density of water is just 1000 times 9.8. So we can stop here, right, at this point. There is no point moving further, because leaving it this way will be of help as we move on. So the next thing we also need to look at is the fact that we have our V total is equal to V aluminum plus V gold, right? Is one of the principal points that you must take note of, that the V total, the volume of the system, is equal to the volume of aluminum plus the volume of gold. Likewise, it also applies to the mass too. We have the mass, total mass of the system is equal to the individual mass of the aluminum plus the individual mass of gold, right? So let's stick with this particular equation and paraphrase by replacing this one with the density and the volume of this, the density and the volume of this. So we have mass total equal to the density of aluminum times the volume of aluminum equal to density of gold times volume of gold, right? And we also know that this particular V total equal to this. Since we're interested in calculating the weight of gold, we can eliminate the volume of aluminum by making VAL the Sevier formula, and that gives us M total equal to density of aluminum equal to V total minus V gold plus this expression. And if we simplify this, we have this expression by expounding. Now, if we take like terms between these two, V gold out, we have M total equal to this expression. We can send this one to this part and divide by this expression to make V gold the Soviet formula. And that gives us these parts. So this is the final formula that we are likely going to use to get our volume of the gold. One, we know mass total. We can easily get mass total. We know this value. We know the volume total. We can easily get it, which we got in the previous slide. We know this. So let's substitute the parameters into this expression and we get the mass total is the mass of the system of the alloy in air divided by 9.8. Sorry, the weight of the alloy in air divided by 9.8 will give us the mass total minus the density of gold, aluminum, 2.7 times 10 raised power 3. Then you remember we derived the expression for V total, which is 11 all over 10 raised power 3 times 9.8 in the previous slide. All over density of gold, density of aluminum, then we can factorize 10 raised power 3 out. Now if we simplify this by taking this and this, right, we'll have this expression. So 2.7 times 11 will give us this expression. And from these points, we can subtract this expression from this and send 9 over 8 to meet this one at the bottom. So we have our V gold to be 15.3 all over 9.8, 1.6 times 10 raised power 3. Okay, at this point, we can even leave our answer in this form or simplify further. But what we now need is the weight of gold. So weight of gold will be equal to the volume of gold, which is this one, times density of gold times G. So if we substitute all these ones into this, and we already know the density of gold, we know G, we can easily calculate the weight of gold, which is 15.3, 9.8, 16 point this and this. Then density of gold is 19.3 times 10 raised by 3 times G. So this will cancel this one out. 9.8 will cancel this one out, leaving 15.3 times 19.3 all over 16.6, which is this expression. And at the end, we get our weight of gold to be 17.79 Newton. I hope this helps. This is one way we can get the weight by the weight of a particular element in an alloy. I hope this helps. Please like, share, and comments. Thank you.